All right, anyone in chat? We are live. All right, let's wait people to gather. If anyone in chat, please let me know that you are there. And we can start. I prepared here a breadboard. So, no one yet? Hi, Squish. How are you? In chat, I believe you are the first one. No one yet. So I was watching the video, the live streaming between James and PCDD Repair, and I saw that they were struggling to understand transistors and to measure a BJT special. So I already told them that I was gonna share my knowledge about the transistors. Yeah, they must be lurking, but they are not here chatting. So only you are the one that he break the ice and start talking to me. That's why I'm waiting to have more. I also text to James that I'm live. Maybe he will gonna be in a second because I'm gonna explain a bit about transistors. So I have also a box with lots of transistors over here to also test few small LD Tech Pro. Good evening. To, to test also some small circuit like that, you understand better how these guys are working. Definitely some resistor can be handy. Maybe I need to gather also some capacitors, and we're gonna figure out a few things. Okay, let me put this box for now up there again, and we're gonna PCDD repair. Good evening. So you can see here I have one multimeter, I have the second multimeter, which is this one, the second one. I can move it where I want on my table. And I have also there displaying, so have a look there. If I switch here, I can see switching between resistors, between everything. So it's really nice. No need connected to the computer, and I displaying over here. And is not that much expensive, this multimeter, that anyone can have it and display nicely on them OBS over here. I can go through all the function. I can see there. I can go back to resistors. We can also test to see if it's doing. I can see it's doing perfectly. And I have another camera over here that I can do some close shots on my breadboard when I'm gonna build up with jumperless the circuits that we're gonna test it tonight, like that you have a understanding about these transistors. And we're gonna see, but I really like that I managed this one to make it work with OBS, and really no cables connected to my computer. Look, nothing. And I can put it where I want, where is comfortable for me, and do everything. This one is still the same, the oven, the XDM 1041 is the one that doesn't have a battery. 1241 has a battery. Yeah, PCDD repair. It's not nice to have a multimeter like that to display on the OBS. Bună dimineața! Aici e seară, e aproape 8:30 seara. The Chips 24. Bo, where is JFix? Mostly I wanted for him because he was struggling to measure a transistor, a BJT. But before measuring and before explaining, I want to let you know. So, we have 3 categories of transistors. So there is the BJTs, which is B-junction transistor. We have the MOSFETs, and actually they don't call it MOSFETs, they call it FETs. So it's field effect transistor, that one. And then we have the IGBTs, which are a combination between FETs and BJT. And then we have the FETs, which are also a subcategory in 2 parts, the MOSFETs and the GFETs. GFETs is a field effect, junction field effect transition, and MOSFET is let me grab the word of MOSFET, is oxide field effect junction, same, but is oxide. Is M, let me understand, because in my language I know from what is standing the M, but let me understand the M, it's coming from metal oxide. So MOSFET is metal oxide field effect junction. JFET is field effect junction. And then we have the IGBTs, which is a mix between them two. So what's the difference between BJT and FETs? The BJT, they get controlled by current. The FETs, they get controlled by voltage. And the IGBT is stand for isolated gate bijunctional transistor, which is a mix between two. So it's acting as a FET, but it's still controlled as a transistor BJT with current. So these are all transistor family. Hello, Carter, how are you? GMC Electronics, hi, good evening. So that's why I'm gonna do part 1 tonight, focus more in BJTs, and then we're gonna talk maybe part 2 and another episodes about FETs, part 3 about MOSFETs, the metal oxide, because there is a difference between them. JFETs are really sensitive. They don't take even 1 milliamp current on the gate, and if you just apply a little bit of voltage higher than the support on the gate, you destroy the transistors. So that's why when you are dealing with JFETs in especially, you must to make sure your soldering station it's ESD safe. If it's not a ESD safe, you destroy the JFET very easy. They are really the most sensitive transistor that exists. Good evening, Swindon Electronic. So, how we are measuring the BJTs? So here I have all of them, BJTs, PNPs, and NPNs. Before reaching to measuring, let's also understand what stand NPN and what stand PNP. So NPN stands for the emitter base collector. So you have the negative, the emitter will gonna always be connected to a negative on the power supply. Positive stand that we need to apply a positive voltage on the base in order to open the transistors, and N on collector stand that any load that you connect to it, you must to connect the load polarity on negative side to the transistors. The PNP is the same. P stand for emitter, that should be tied straight away to the positive of the power supply. N is telling us that we need to apply a negative voltage on the base in order to open the transistor, and the positive is the collector that is telling you that the load, if it's a polarity load, you need to connect the positive on the transistor. I hope that you understand so far this terminology on the BJT transistors. So Squishworm says 0607 volts. Yuri, about what you are talking over there? So every transistor has a data sheet, and on the data sheet we're gonna tell you the voltage that you can apply on the base, respect the collector side and respect of the emitter side. So if you stay in that parameters what the data sheet say, the current, the less current you apply on it or the more amount of current, is the way that you are biasing the transistor, opening more or closing the transistor. So just bear in mind. But if you overclose the thresholds that is mentioned on the data sheets of each individual transistor, you destroy the transistors. But I say you need to look for the base emitter voltage and the base collector voltage, and you need to depend of your circuit that you want to build up, or depend on where it's used. There is the threshold that you can open and close more the transistor. So 8-bit repair, good evening. So that's why let's have a look here what we have. So I just grabbed one from there. So it's telling me, I believe is a BC327. I'm gonna also get this one, because also here when they test it, they say that there is hash phi. So hash phi, what is the factor of amplification of the transistor, and is a piece of information that if we go to check the datasheet, we can understand if the transistors is genuine, original, or is China fake. So I'm gonna also open a datasheet of this transistor, and we're gonna also test. So I can see here, I'm gonna bring it closer. Actually, I'm gonna bring it here like that you can see better. If this one want to focus, my camera. Okay, so I can see it says the hash fee. Oh, you switch it off. So I can see the hash fee is 334 and is BC327. So let me open the datasheet of BC327. And we're gonna have a look over there. Okay, so let me put on my screen over here the datasheet. And let's walk through. So as I say, we have that piece of information, which is called hash fee, and on the data sheet, it's this one over here. If you see here, this in current gain, so it's the factor of the amplification. And here is telling you if it was applied between the voltage on the base between collector and emitter at -1 volt and 100 milliamps, you should get between 100 and 630. So this one is telling us is 334, so can be a genuine one. If my have higher than this number or less than this number, definitely is a fake and is not this transistor totally. So that's why with that piece of information, we can compare with the datasheet to understand if it's the right transistor or maybe it's call it a BC327, but actually is something China fake. So that is the information that you get there with the hash fee when you check the hash fee. Yeah, hash fee or beta is the same things, like factor of amplification of the transistor. And as I say, if you go to the data sheet and then you compare it, you can understand actually if it's a genuine transistor or if it's a fake one. So apparently this one is staying on that numbers and looks like can be a genuine. Anyway, are China kits, so you will never know. So this is a PNP. Let me also get his companion NPN, because this one sometimes they making in pairs. So his companion is the 337, which is a NPN. So let me grab one. And let's see also his companion, if it's a genuine or not a genuine. So this one, it says that is 485, right? Hash fee. So let's have a look at the datasheet of this guy. All right, so let me bring it on the screen right now. So this is his companion, the 337, which is complementary to 327. And I forgot how much was the number. So it's 485, the hash fee. So we are going to check the hash fee over here on the datasheet. Where I think is down here. No. Where is the hash fee? So current gain bandwidth. So the hash fee is this one. This is current gain, and you have more types. So you have the standard BC337, then you have the BC33725 and the BC33740, which you can see stand on different hash fee. So The one that I have here might be the 40 because has 485 hash fees, so it's standing between 250 to 630. So might be that one. It doesn't give me that information if it's 40 or no. Actually, yeah, I think I have the 40 over there. I need to put under the microscope in order to show you. But I can see there is a 40 mention it. So yeah. So it's this one that the factor of the amplification is the highest one from all of them. Or can be the standard one. Looks like also this one go up to 630. But if in case you find one which is less than 250, definitely you can include it on this category, the 25. And if you might find any transistor that is less than 160, definitely you can include it on this category, the just simple BC337. So that's what can tell you the information hash fee. So Stu2B2, good evening to, but I don't see yet JFix around. And I already told him that I was gonna do that one, and he was happy and can't wait to have a look. And how we measuring these transistors? So this is the NPN. I'm gonna put it over here, and this is the PNP. We're gonna test again to understand the pin out. So I have middle pin is base, then I have collector and emitter, right? So base, collector, and emitter. Let's check the companion one. Should be exactly the same, only that is a PNP one. So let me get the pin. So yeah, base, collector, and emitter. So here we go. And I'm gonna use the white multimeter over there to measure. So pay attention on that one. So we need to go to put on diode mode. And we go to the, so the NPN, you go always with the red on the base, and you need to have a reading between base and emitter, and you need to have exactly the same reading between base and emitter, as you can see there. Then if you put the black to the base, you don't need to have any readings, neither there and neither there. And then you don't have to have also any readings between collector and emitter, neither this side, neither this side. So once you did these three measurements, you got these readings, you are sure that that transistor is okay. For the PNP, it's the opposite. You go with the black, with the ground probe on the base, and you have base collector 716 reading. The same reading you need to have also with the emitter 716. Then again, between collector and emitter, nothing. And if you swap the probes between the base and collector, nothing. And between the base and emitter, again, no readings. So that's how you measure the BJTs with the multimeter, and you make sure that are okay. If you get readings in both directions, the transistor is just chuck in the bin. No, if it's showing slightly higher than the collector, it's not a perfect transistor. That one has a problem with the emitter. The junction has suffered, and it's still good, but it's not how it should be. You should have exactly the same readings. In my limited experience, you can tell the difference between the real and fakes by looking at them, depending on you have a real one as reference, but the ultimate test is gonna always be under load. You cannot do this small transistor under load. They are not carry on any load. They are mostly few milliamps. So if you want really to understand, when you go with the power transistors, like these ones, like these ones, yeah, this one, they can carry load because they meant to don't amplify signal. They made to hold current. So that's why if I need this one to test with my HV tester, you must, to make sure that is a genuine transistor, you need to have really low HV, sometimes maximum at 40, but really low. If you find with really low, you are sure is a power transistor and is a genuine. If you have like a power transistor that measuring on HV over 100 or higher, that is not a genuine power transistor. The power transistor I made to handle loads, but to don't amplify signals. So that's why on amplifiers, on the first stage, you have small transistors that amplify the signal. So they're amplifying the voltage. And then on the final stage, in the power stage, you have the power transistor to sustain the current on the voltage that these small guys amplifying. This is how you can work out which leg is a meter if you have no data sheet. Yeah, mostly I use this one. It's not accurate, so you cannot base like, oh my god, this is a high piece of equipment on your lab, but it's very easy, very handy, very fast to read out the pinout and to know the orientation of the pins. So mostly when I use this one, I use mostly to, because also the HV, you are not very sure on this one. You need to put there a 5% tolerance on the number that you read. But when I need to match the transistor, if the PNP is telling me, let's see, 100 HVE, and I need to pair with the NPN, I'm gonna go to look for another one that it will gonna give me that number, same 100 HVE, and I'm sure that no matter the tolerance is inside of this device, 5%, 10%, but if for the PNP give me 100 HVE and for the NPN give me 100 HVE, this means are much pair in order that I can have a good amplification in both sides of the signal, the positive and the negative side. So let me go a bit through this chat. I might miss any. Is Lenovo Vantage okay to limit battery charging, or should I look for another smarter program? Well, I don't know to answer this question. I never test this Vantage, Lenovo Vantage, which you say, and I never try to, like how other YouTube channel which are repairing laptops, they have this battery device that is reading all the information about the battery. So if you're looking for an answer for that one, I can say Laptop Fix. I saw that he has this device that reading batteries, and he can give you better explanation on that question. I know also James is looking to find one of that read the device that unlock and read batteries. So he don't have yet, but I'm pretty sure he have. I know also Sorin have that device, so more luck to have an answer, I think, is Laptop Fix, because whenever I comment on Sorin videos and I ask some question, he never answer me. So that's why I can't tell you more on that one. Really sorry, I can't give you any right information about your question with the Lenovo Vantage. If anyone in chat knows about that one, please let know the Chips24 an answer to his question, because I say I don't have an answer for that. Here is hello, hello, hello. So from that one we already gone. This one with the limited experience, I already read it and I already give an answer. And the last one from my squish worm about that you don't have a data sheet to understand the pins, and that one I say, yeah, this is really handy. £6, how much costing, I believe. I say it's not an accurate piece of device, but for fast understanding the pin out of the transistor and also telling you if it's a good component or bad one, you just stick in, you press the button and it's telling you. I say, are not the most accurate readings that is giving you, but at least you have the information if the transistor is okay or is not okay. So next we're gonna see some small circuits that we can do with transistors to understand difference and what they are doing. Because I say, this transistor can be used on switching on and off devices, and can be used to amplify signals. So I'm gonna show you both of them, like how you amplify the signal and what you need to do to the transistor in order to amplify a signal, and how simple it is to use it as a switch, because for amplifying a signal, you must bias the transistor correctly in order to get the right amplification outside from it. I wonder how a factory makes cheap counterfeit transistor. Do they buy all the equipment? Maybe. No, so
Thanks for the sub.
Thank you so much, Darren Davis. I really appreciate that. So how they do these fake transistors? Because when they make a silicon transistor, they make those big discs and then they section it small pieces for making I don't know how many transistors. And when they test the batch, because not all the time when they build up, when they make up the silicon thing, not all the time it will gonna take also we're gonna come sure on the right parameters. So when they make the transistor and then they measure all the parameters according with the data sheet, and if something is not okay, the transistor are good, but I believe someone they buy like that stock of counterfeit, because it's not counterfeit, are not matching properly the data sheets, and they stamp a number there and then they say, okay, this is this type of transistor. They don't care, it's selling cheaper, and who wants to buy it, he buy it. Yeah, because they never make all the silicon things, you know. I think if you go on YouTube and you search how a transistor is made, it will gonna give you all the process. Like they first make that disc of silicons and then they cut small pieces and take the small parts and make this capsule, connect the leads, and then test if the parameters are matching the data sheet that they meant to be that silicon made. And if no, some third party, I think they buy the transistor that are not on the right parameters. They put the stamp on and they say this is this type of transistor. Yeah, they are reject piles, are still good transistor working, but if you need to test them on the parameters that the data sheet is telling you that that transistor can do the job, we're gonna fail in some of them. So that's why the manufacturer for reseller suppliers, they can't give that transistor as a good one, because the reseller, then it will gonna get a bad face on the front of the customer. You sell me something that doesn't match the data sheet. But the factory, to don't lose so much money, because maybe when they made a silicon, things didn't match perfectly the data sheet for it, is finding these third-party resellers that they don't care about them face, and they say, okay, I have this batch of good transistor, but they meant to be, let's see, BC327, but something on data sheet is not correctly. So if you want them, you can get them. Yeah. Good evening, James. You come late. You already miss explanation about which type of transistors we have, what it stand the NPN and PNP. You miss a lot. I was waiting for you, but then the chat start gathering people, so I say, okay, let's start explaining about this one, because also I will not stay too long tonight, maybe around 9:45-ish maximum, because yeah, I did those streams last week, evening after evening, and then the next day at work I was feeling so tired. So yeah, I want to explain about transistor, and yeah, watch, because it's a good information, piece of information that it will gonna explain you what's mean the PNP, what's mean the NPN. I already show how to measure correctly transistor to make sure it's a good one or it's a bad one. I already explained the hash fee, which piece of information contain that one. So yeah, if you join later, I will not repeat it again, because I want now just to build a simple circuit here in the breadboard with jumper leads, and put a little power on my power supply, do a few measurements, and also oscilloscope for the circuit that I say I'm gonna build one as a switching, and I'm gonna build another one as amplifying the signal. So let me also get some capacitors, because I need also a few capacitors. And also this one to be ready here, because I might need some resistors, and I have few values over there. But let me first get from here, just can get some 10 microfarads over there. Let me get two of them. Then let me get also 4.7 microfarads over there. Let's get two of them. And we should be okay. What happened to this one? He banned it. Alright, so I say the 337 should be our NPN. So I'm gonna start with the NPN. So this one, the NPN, right? We can check again quick with this one, because it's handy. And we have yeah, NPN. Alright, so we know that this is the collector, right? So we're gonna put it back there. So we have collector, base, emitter. And as I say, or NPN, it's mean the emitter always needs to be tighted to ground, right? So let me see which resistors are this one. So let me put on resistance mode over there. Let me see which resistors I have here gathered on my table. So this is 1K. I might need let's see, a 50K if I can find one. This is 1.4K, so we are checking this white one. Let me see what I have here, because I say I'm gonna build a circuit from my head like that. So this is 1 meg ohm. This is too high. Look, I think I found a 47K, which is the color yellow, purple, orange. And as I say, it's a 47K, this one. Yeah, I can see there 46.65. So I say this is the emitter in this side. So let's put the transistor a bit over here. And I say the blue line, it will gonna be our negative, and the red one, it will gonna be our positive. Okay, so I'm gonna put from the negative to emitter this resistor, because I say the transistor needs to be to emitter to ground, and then we're gonna put a capacitor from his same from the emitter. So we are going to put the positive on the emitter, on the capacitor, and I'm gonna tell you why in a second. Because as amplifier, it will gonna amplify the signal between emitter and ground. So when you connect the call it load to it, you need to connect the negative of the capacitor to the negative of the power supply through your load. So that's why negative always on the other side. Good evening, Steven PMD. Good evening, Andrew. Where is the best to buy quality components? So the trusted one, you have like Mouser, the big one. Then you have the Farnell. Then you have this RSUK, or you have yeah, this one are the big distributor of the original parts. Capacitor seems different, so I don't think they are factory rejects, or it will quite interesting to know how factory rejects. Yeah, also the capacitor, they need to go to a quality check, and if the batch is not okay, because I bought some capacitors from China which say 10,000 microfarads. I measure it, they even not reaching 4,700. So how you sell a 10,000 microfarad if it's not even 5,000? Yeah, DGK also is a good, CPC also is a good trusted reseller. So then we were gonna use a 1K from the collector to the positive, and then now we need to bias the transistor on the gate. So here I really need to find two of 10K or 12K resistors. So remember, I had some yesterday. I went through all my boxes because I was looking for something, and I spot some 12K resistor up there, which are this one, brown, red, orange. So we have the 12K resistors over here. So I need two of them, because I need to bias the transistor. and biasing the transistor, we go to these 12Ks. So biasing the transistor, you need to put from the ground to the base, and let me see how I can stick another transistor over there. So I'm gonna move this one to the next hole over there. Like that I can put from the base to ground over there a resistor. And then to bias correctly, another 12K from the base to positive. So that's our base and that's our positive. So then we need another. So let me see which capacitor I use here. So I use a 4.7, and I'm gonna use another 4.7 on the base. That's the base. Same. Positive goes to the base of the capacitor, and negative of the capacitor on the input. And we will gonna now hook up few wires. So we have our positive power supply over here. So we're gonna have our negative power supply over here. So let me put them on this one because the power supply is in this side. So we have positive and negative. Actually, if I have a block, I'm gonna use a block for negative. This is not what I need. Are not the right jumper leads. Let me get the box of jumper leads. And let me get from this box the right leads I need. Let me find a black one. Yeah, look, I find the black one over here. So let's put the negative with black. Then we need to use for injecting the signal to show you how we amplify it, because this what I build here is how transistor act as amplifier of the signal. So let me get this so I'm gonna have the input over here, which I'm gonna use this orange, and I'm gonna have the ground for the injecting the signal, and I'm gonna read the signal through this yellow, and let me get another a blue one. Let's put a blue one, the ground, to see the signal that comes out from this tiny little amplifier which I built here. I say from my head, no things. Before to power this circuit, let's go back to the datasheet. And I say this is our NPN transistor on the datasheet, which is this one, NPN amplifier transistors. And we need to make sure here. So we need to make sure that we will not apply a more higher voltage than 45 volts on it, because otherwise transistor will gonna die. We need to know that between base and collector and base voltage, we can go up to 50 volts, and we need to make sure that between emitter and base voltage we can't across 5 volts, because otherwise the transistor will gonna die. And what again we're gonna know here in collector current continuous. So we need to know that we can drive a load not over 800 milliamps. So if we put to switch on and off a LED, let's say, you need to make sure that you cannot put too many in parallel, because it will gonna draw more current over 800 milliamps and you can destroy the transistor. And here we know also that on the total dissipation power at 25 degrees Celsius, we're gonna dissipate 625 milliwatt. So it's like 5 milliwatt per grad Celsius. And we need to know that the thermal resistance junction to ambient is 200 Celsius per watt. And also the thermal resistance junction to case is 83.3 Celsius to watt. So with this information, now we know that we can power this transistor no more than that voltage. We can go to the base collector base voltage up to 50, but we need to make sure that here the voltage is below 5 volts. All right, so I'm gonna start powering my device over here with the 15 volts. So let me set up my power supply to 15 volts. And I'm gonna apply no more than 800 milliamps to don't destroy the transistor. Why you go there when you need to go here? All right, so I need to do one here. The second, because my okay, so let me go to 800 milliamps over there. So 15 volts and 800 milliamps. I can see in my power supply already we have 15 volts over there. And we can power. So I say this is the ground, goes to ground. And this is the positive, goes to positive. And now I'm gonna measure some voltages across the transistor to make sure that I'm staying on the right parameters. So I say that between collector and base, I should have no more than 50 volts, so it will not be the case. So we have some 7 volts, and between the base and emitter, less than 5 volts. So I can see we have only 541 millivolts. So we can still increase the voltage on the powering this transistor, because we have a lots of room that we can go more. So I can see it's just only 541 millivolts, or between the base and the collector, right? It was there. So let me run. So between base and emitter, yeah. So we say that our emitter is in this side, right? Let me try again. Make sure the emitter is in there. You don't stay good there, attach it. Let me put you in the other 3 points. Yeah, so emitter is in this side, so we know that in emitter we are less than 5 volts. So now we should practically have a kind of amplification over here. So let me bring the oscilloscope on the screen, because we need the oscilloscope on the screen. Okay, let me move it on this corner. And then let me bring my circuit down here. And then I'm gonna need one lead. Just let me get my lead over there. Where are you? I'm gonna touch it there. No? Yeah. So let me get my lead. Without making too much mess around. And I'm gonna attach it to my signal generator over here. So I find the power supply of this one. So now I can use my preferred one, the oven one. But before starting, let me check a bit on my little boy, okay, guys? Right, he's still in his bed, but not sleeping because he had a nap today. And when he have nap during the day, hard to make him sleep. Right, so let me turn my signal generator on. And I'm gonna inject 1 kilohertz. So let me go to 1 kilohertz. Right, 1 kilohertz, and I'm gonna say an amplitude of 500 millivolts peak to peak. So I say I need to connect ground to ground. I hope that I will not do many shorts around here. So ground to ground and positive to positive the signal. I'm gonna also connect here one of my oscilloscope probes. So signal is signal over here, and we have the ground over there. And on the output, I'm gonna connect the other leads. So this is my output over here, and this is my ground over there. Let me turn on the signal generator, and let me go to my oscilloscope here on the screen to give an auto set and to see what we are reading. So definitely we have a lot of noise because I say I'm just injecting 500 millivolts peak to peak. And if you can see here, we have the 1 kilohertz frequency reading both channels. And it's almost the same on the input and on the output. Let's try to increase the signal. And let me now give a auto set. And looks like it's not amplifying nothing. It's like what we are putting in, we are also putting out. So now that we know the circuit is working but is not amplifying, we can play with the resistor that goes to emitter, to the ground. Like that, we can allow more voltage on the base. So base emitter, we was measuring only 500 millivolts. So I can change the value of that one, reducing increasing the resistance, and we should get more amplification on the output. So let's try. So now I have there 12K. So let me try to see if I find the 22K and see what's going on. So I don't find 22, but I find 2 of 46. So 2 in parallel 46 will gonna give me a 23. So are those two. So let me switch off the power supply, and we're gonna change those dot resistor. So the power supply is off, and you can see I have only signal on the input. On the output, I don't have nothing. The yellow is our output, so the red is input. You can see here, this is the red one. See? So on the input, we still have the signal, but on the output, the signal is disappeared because we power off the circuit. Hi, Grandpa. Good evening. So I'm gonna switch off the signal generator. Like that, we're gonna disappear also the signal on the input. And let me now do that what I said, to put, instead of this 12K, let's put 22K. Right, so I will not have space to squeeze them there. So I'm gonna put them here aside. So I'm going to put them here aside, from there to ground. And I'm gonna use a jumper lead from the base to those resistors. So let me find a jumper lead. So this is my jumper lead. So I'm gonna stick on the base over there, and I'm gonna go to these resistors. Now I'm going to power on again the power supply. So you can see we have our 15 volts over there. And let me measure also now to the base which voltage we have. So this is my base, and that's my ground. So no, I need to measure between here and here, sorry. So nothing changed, still only 554 millivolts. Right, maybe I can increase my supply voltage to 20 volts. So let me increase my 20 volts power supply. So I increase it to 20 volts. And let's see now which voltage I have between the gate and the emitter. So I can see now we have a little bit higher, is 562. And to bring it more higher, I can reduce also the base resistor to positive, which now is 12, but maybe I can reduce it to a 5K, and it will gonna increase the voltage over there. But let's see now if we have any amplification. So turning on this guy, on the readings.
Thanks for the sub.
Thank you so much. I didn't manage to see who subscribed because the oscilloscope, it's Sojipio. whatever I need to pronounce that name, I'm not sure. So I was covering with this one, so maybe I can put it here like that we can see also who is subscribing. So reading the parameters, still we don't have any amplification. Still what we are putting in, we're taking out. So now let me try to change that resistor, the base to positive, and see if we change anything there. So powering off the device. Again, we're gonna have only on the input the signal and the output no signal. Let me switch off also that signal. And let me try to see if I can find maybe a 4.7K there, something like that. So I find a 2.2K, red, and yellow, violet, and red, which is 4.7K. So let's change this guy, which I say is 12K, to a 4.7K.
Thanks for the sub.
Thank you so much, Los Boo, something like that it says there. Los B. Thank you so much for subscribing. So now we have that one. Now let me reduce back to 15 volts the power supply to see what is changing there, because I don't want to cross that 5 volts on the gate, on the base. And let's power on. Let's measure the voltages across that transistor. So I say between the base and collector, let's see what are the readings. So we have 1 volt over there. Oh, yeah, 1 volt. And between the base and emitter, 559 millivolts. Now let me increase it to 20 volts, because I have room. So let me go to 20 volts and turn it on, and I can measure again. So between base and collector we have 1.4, and between base and emitter, if my leads they don't get all messed around, we have 566 millivolts. So let's inject the voltage, the signal, and see what's happening. So injecting the signal, we still don't have amplification. All right. So in this case, I'm going to do also another thing. So let me power off. And I'm going to put straight away the voltage without resistor on the collector. So let me find the jumper lead. And between the collector and positive, we get off the resistor. So let me now set up again to 15 volts and turn it on. And on the output, On the output, I think we have slightly Soli amplification. So let's understand which one is the channel one. So this is our channel one, right? Because I still have the signal only on the output. So the output is channel 2. So channel 1 is the input. And looks like there is slightly, not too much. Let me give also an auto set. Right. And let me also try another thing, because we can take the signal out also through the collector. So let me now switch off the power supply and try to get the signal out from the collector. So this is my output capacitor over here. So I'm going to connect it to the collector. But now I need to put the resistor back. So I'm going to put that 1K resistor back over there to the positive. And I'm going to connect the output over here to the capacitor, to the collector. And let's see now what's happening. So let me turn it on. So 15 volts power supply. And here, trying to get the signal from the collector, looks like we don't get anything out from it. We get less. So now we create a buffer instead of an amplification. So on the collector, you made a buffer. On the emitter, you do an amplification, but we are not getting that gain. So in order to get the gain, let me see what else I need to do. Let me go a bit through the chat. All right, you should watch PCDD face reveal stream later. If you anticipate talking with someone else, because I was there watching today. Big gun with flatliner. No, we just take off the power. So yeah, so here in the collector, we are creating a buffer. And on the emitter, still, we are getting the signal out, but missing our amplification. So it's missing our amplification on the emitter. So what should I do to get that amplification? I'm gonna try to come with just 1K over there, actually 1K, 2.2K. Let's reduce more the resistance on the base, like that we can put a bit more voltage on the base. And let me just where is my resistor that goes? Ah, is there. So let's keep same, the 23K on the to the negative side from the base. And let's turn it on to see what's going on. And here I think we have something. Let's have a look. Let's have a look. Still we are not getting the amplification, so it's really strange. We should get an amplification. Let me try to put a bit more voltage on the signal. What happened here? Oh, I switch it off. It's on. Yeah, I switch it off. So let me increase here the input signal. Let's increase the input signal. And let's see if it's anything changing. Still no amplification, so we're taking out from the transistor whatever we're putting in. All right, so I'm gonna try to measure a bit this voltage again against the base emitter we have in 600 millivolts, and base collector we are 1.6. So I'm gonna try to eliminate that 1K resistor there, but let me power off the power supply. Tight it straight away to the positive. Let's see, it's giving me anything else now. Now, because the transistor is not biased correctly, you can notice on the signal it's all flattened. So we are getting distortions. So now the signal that this circuit can get, it's only that maximum. So only 2.4 peak to peak. So increasing that resistor, we can put more signal on the input before the transistor go in clipping. See, when it's flattening like that, the signal, we have a problem. So that's why I need to put back that transistor. The resistor, sorry. So the power supply is off. I'm gonna put back the resistor. Actually, let me put a 4.7 also here. Let's turn it on now. So it's on. Let's see now if it allows us to put more voltage on the base. Yeah, allows us to put, but still there is no that amplification. I should have a sort of the amplification. Let's have a look to a simple amplification signal on Google to see if I might miss anything, because that's the circuit how it should be, but I don't get amplification. Maybe the transistor is not doing what it should do. So let me quick go to internet to look for just a simple amplification schematic. All right, so what I built on my breadboard is something like this one. So now I know what I'm missing. Have you spotted what I'm missing? This. So let's add that capacitor. Let's see what's happening when we add that capacitor, because that's what I am missing. And then again, maybe we can also try this version when we want to take the signal from the collector. So let me first adding that capacitor over there and let's see what's happening, all right? So yeah, what do you think? What it will gonna happen when we're gonna add that capacitor over there? It might change anything? Let's have a look. All right, so first we're gonna turn off the power supply. Gonna turn off the signal and also reduce it because I'm expecting now to have some amplification. And now let's put 10 microfarad in parallel with our resistors from the emitter to ground. So those are our resistors down there. So I just need to stick this capacitor between them over there. So let me just make me one hole empty over there. And no, that is the base. So it's in parallel with this guy over here. This is our emitter. This is our emitter. So I need to put in parallel with this resistor my capacitor. Right? So that is a 10 microfarad capacitor. Now let's turn on the power supply. The power supply is on. Now let's measuring the voltages across the transistor. So here we still have a 560 millivolts to the emitter, and to the collector we have minus 45 millivolts. Really less. So we are not powering the transistor at all. So let me put 1K resistor over there to give at least 1 volt on it. I'm going to put the 1K over here. Turn on. And let's measure again. Base, collector. So we are about 1 volt, which is okay. And base emitter, 558 millivolts. Right, let's inject the signal. Do we get that amplification? Nothing. Again, still acting as a buffer if we put the capacitor there. And according with the schematic that we just watched, we should get an amplification. But now we don't get anything properly, nothing on the output of our amplification over here. Definitely is powered on, right? Yeah, it's powered on, but nothing. So if I go to just remove the capacitor, the signal comes. So it's something weird also with that schematic which we saw it just before. Alright, let's look again to that schematic. Maybe we can find one that is telling us the values. Alright, so let's go there. Alright, let me go to my page over here. Because I saw one, it just tells me some values over here. Right, this one. So here I have 1K, so it's alright. Here I have quite high, so I can bring again also here 1K. Here I can just bring less. And I think this is the trick. Reducing this resistor, we get more amplification. So let's try reduce this resistor. Because here is telling me that it's just 565 ohms and I have 22K. So let's try to replicate this one. Let's see what's happening. Let's see if it's true or no. If it's even like that, will not amplify the signal. This means the transistor is not working as should. So let me find a 680 ohm, something like that. I'm here on my box looking for the resistor. Do I find anything close to that value? The 200 ohms over here. Only 200 ohms. This is a. So I might use three 200 ohms in series, and like that I can have like 660 ohms. So I have three of 220 ohms there in series. So we're gonna change those there. This one too, they can come out from here. And we can add the 600 ohms. So I have one, two in series, and three in series, and we have there that value. So let's change also that resistor, what it says there. Let me have a quick snitch. So the one that we change over there, we changed the wrong one. So I need to move this one over here to the emitter over there. And then I say I have on the base, from the positive and negative, I should have 1K and 1K. That's 1K and another 1K. And we're going to use also another 1K to don't put straight away on the collector, tied it to positive to pass it through a resistor. And try now to power. So if it even now doesn't do an amplification, this means the transistor is not doing what it should do. Right. There we should be alright. Now let's try to increase the voltage over here. And still no amplification. So I believe transistor is not doing what should do. Let me try another NPN from here and just try to change the transistor. Because now we are exactly on that schematic that is show us there on the Google. So we get this out. Let me find another NPN. So 2N222 should be an NPN. So let's get that one. And let's see if changing the transistor we get amplification or no. Again, it's not doing contacts over there. All right, so emitter is number 3, base and collector. So it should be, just place it on the same place. Let's turn on the power supply. And we say the channel 1 is the input, right? Yeah. Looks like this one reducing the amplification. So we are putting in 3 volts peak to peak and we are taking out just 2 volts peak to peak. So apparently there is no amplification. It's same as a buffer zone. Bye bye worms. This is an NPN because it's a schematic that is connected collector to the positive. So only the NPN you can connect it to the positive with the collector. If it was a PNP, you need to put it on totally opposite side and apply on the signal here a negative signal. No, it's an NPN, this one. Ah, sorry. So this means it's messed up because 2N222 is a NPN transistor, not PNP. So I take it from that slot. So this means we have a wrong transistor on the slot. I didn't check on that. I didn't look at it. I just want to know the pins. Sorry, guys. Thank you that you tell me. That's why we don't have any amplification, because it's powered incorrectly. Definitely it's not burnout because we are not using over voltages. I can test it. It's not burnout because we are not using over voltages. But definitely still should be a 222 over here. Just from this slot should be the 222s. And 222s is an NPN. Yeah, 222. This one. And yeah, this one is not a 222. This one is a 327. That should be here. So that was the problem. Thanks that you see it. So 222 is an NPN. I know the transistor. See? NPN, yeah. NPN. Only that here is changing the things. Here is changing. Here I have emitter on the pin number 1, base on that one, and collector there. So this one should be turned around like that. But this one has a different pin out. All right, let's turn on, let's see. Do we get that amplification? No, whatever we are putting in is coming out. So no amplification at all. So you can see here this number, I'm looking for this number, or for this VRMS. So it looks like what we're putting in is coming out. So no amplification. So let's go back to the internet to see which one it will gonna amplify for me the signal. Because we need to find something that amplify the signal. So let's go to image, and to figure out one that we will gonna see that amplification, because we need to see on the output more than in the input. So that's what we are looking for. Because the circuit is working, but it's not amplifying. So that's what I need to understand why. Let me just find a quick, not with 2 transistors, I just want with 1. because 1 should do his amplification by itself. So where we have 1, I'm might try in this case, because I know also from the collector we can amplify the signal. And to amplify from the collector, I saw 1, but I can't see it now. To amplify from the collector, we can try this one. We can try this one to amplify through the collector. So I have almost these values here on the table. So let's build up straight away. So the schematic says like that. The power is off, right? So let me turn off also the signal. And it says that I have the capacitor to the base, 47K to the positive. So let me put the 47K to the positive over there. So 47K is this one. So it's gonna go to the positive. From the base, and then from the base to ground I have 1K. So this is 1 mic K. To the ground we're gonna have 1K. Then let me take a bit these jumpers out. Then now we're gonna take the signal from the collector. So from the collector, this side is the collector. We have a 4.7K to positive. So this is our collector, positive, 4.7K. No, this is 47. Where's my 4.7K? This is 4.7K. 4.7K to positive over here. And I need another 4.7K. So give me a second, guys, to find another 4.7K. I can't find another 4.7K. What's going on? Alright, no worries. Do I have 2.2? I might need to find another 2.2. So let me see if I find the second 2.2. There's no chance even that one in this box. I need to go through my big bags of stuff. I don't want to bring them now, the big boxes and stuff like that. So 2 12ths in parallel is giving me 6. Still high. Still high. I have these with 5 bands. Let me measure them, because I don't know exactly the. From my head, I always get confused with the 5 bands. With the 3 bands, I know them perfectly from my head. But the 5 bands, I always get confused a bit. So let me do 2 readings on those 5 bands, see what I have around those of 5 bands resistors. We go here for the resistance mode. Resistance mode. Let me see this 5 bands resistor, which value they have. So I always get confused with them. So this guy, first guy over here, is 1.9, so it's 2K. This one is 1K. This one 100K. This is 99. So I have 2K with 2K. I can put them in series. No need properly to be exactly like there. We just need to see a bit of the amplification. This is what we want to understand. 1.9. No, it's 1.9 or... Yeah, 1.9. Let me give a quick measure on these sets. 4.6 kilo ohm. Look, where is our 4.6? Right. Let's get one from here. And goes from the base to positive. So base to positive. And now let me have a look. So collector to positive should be 4.7K. Base to positive 4.7K. Base to negative 1K. And then emitter to negative 1K. So we go emitter to negative 1K. And should be a 20 microfarad capacitor, but I'm going to use 10 microfarad capacitor. That's not that much importance. And we are taking the signal from the collector. So our collector is in this side. So let's put the capacitor on the collector. Connect our output over there. And we should ready to go. And it will gonna be the last trial. Because I said I'm gonna make more parts. This is part 1. I want to keep them not too long. I already overcrossed my time that I was allowing me to do this video, but I'm gonna do this try. If it doesn't work, we're gonna come with a part 2 in another evening. If tomorrow it's okay, same a short one. And then maybe on Friday, when I can stay longer, we're gonna work on the Krell, because I got all the parts and I can show you all the parts before we closing this stream. Alright, so let me get the power supply on. So power supply on. We can turn on the signal. And here we go. This is what we want to see. The amplification. And here we go. The amplification now is there. So let me just go to my signal generator to reduce the input signal, because we have a lot of distortion over there. So let's get that line. The problem is that we have only 100 millivolt peak to peak, but we are amplifying only half wave. So still not good. Still not good. So we are amplifying only half wave. So what can cause that? Let's try to change the transistor. Actually, let me just measure a bit the voltages across the across the pin of the transistor. So we have the base emitter 620. No, this is base collect. No, base emitter. Yeah, base emitter 600 millivolts. So we are in parameters, and base collector 3 volts. So we are in his parameters. So, but still something is wrong on the amplifier because we are amplifying only half wave. We should amplify, because you can see here, if you're reading this, we are putting in only 31 millivolts RMS, and we are getting out 4 volts RMS, but only half wave is amplifying. So something that we need to dig more. So if I reduce, that's maximum what we can amplify to have a full sine wave. So we can see there we have a full sine wave. So we are putting in only 14 millivolts signal, and we are getting out 2 volts signal. Here you see too much noise, because on that very small signal, definitely the oscilloscope is picking up noise from here. So that noise that you see on the red line, forget about that noise. That's noise that's picking up around here. But you can see the numbers clearly that we are putting only 14 millivolts and we are getting 2 volts in the output. So that's really that we managed. So here I see someone, Necropans. Good evening. So we can see clear that the amplifier transistor amplified the signal. So that's what we wanted to see. Wait a second, because I was thinking touching 2 resistors. No, they are touching what should be. So forget about this noise that you see around this red line. That's noise that is picking up around here my oscilloscope, because it's very tiny signal. Imagine only 100 millivolts peak to peak, and is amplifying to 7 volts peak to peak. So try to do a math, multiply 100 millivolts with which number to get to 7 volts peak to peak. And now in order to can read allowed more signal on the input over here to don't pick up too much noise, we can just play around now with the value of those resistors which are on the schematic, and we can maybe allow us to put on the input a 1 volt signal, and to get on the output over here same, like 7 volts output. And thank you that you noticed that that one, when I put it there, it was PNP. But I say, usually I keep organized all my transistors. So I can see first is this model, second is this model, and third should be not this model. So definitely if you are not seeing. So let me put back to overhead. And let me now close this, because we know that is working. So next episode we're gonna work how is switching, how you can use this transistor, the same transistor that we're using now for amplifying the signal. We can use it as a to switch on and off stuff. So let me just open this here. So thank you that you notice about the PNP and NPN. You can see here I'm always keep organize my things. So you can see clear the third box should be the 2N222, which is an NPN transistor, which I know very well. This transistor I'm using in a lots of tinkering around. And definitely, if you watch again the stream, I take the transistor from the third one. Apparently, it was messed up, one from the first box on here. That give me, because I have, no, from his box it was his, because I have NPN, PNP, NPN, PNP, which are like, they can be used as a pair transistors. And then I have like this one, see, 8550 and 85 is the same like PNP and NPN. This one also PNP and NPN. And this one with this one, same PNP and NPN. So definitely I get from here the transistor, but apparently I didn't pay attention to read that one. I was just focusing on the pinout, not on the type of transistor, and I get confused. So yeah, guys, I will not keep it longer because I say I did those 2 nights last week, day by day, and at the third day I was feeling so tired, sleeping only like 4 hours a night because every day I'm waking up at 5 a.m. Time to dress myself up, have a coffee before I left the house. Usually I leave the house like 6 a.m. something like that, and I reach at work by 7 a.m. Actually, I reach a bit early. I reach there like 6:40, but 20 minutes, have a cigarette, another coffee at work, and then 7 I start working. And I finish my duty at 3:30 every day. Yeah, I will try to see. Look, oh, Laptop Fix, how are you? Why you come late? You lost everything what I explained about transistor, and this is only first part about how you use a transistor to amplify a signal. There's going to be part 2, the same transistor which I use it now, how to switch on and off things. And then maybe we're going to pass over to a MOSFET or to a FET. I don't have too much GFETs over here, but definitely I can find 1 or 2. Because I say those are very sensitive. If you keep them in plastics like that, not ESD, they can destroy by themselves very easy. The JFETs. The JFETs are the most sensitive components that there is. Erdemelora, good evening. You are very hardworking man. Good. God bless you. Thank you so much for the kind words. I really appreciate them. Yeah, so like I say, I want to share a bit of knowledge. So have you seen the first time when I build up the circuit over here on the breadboard, everything from my head. I know how things they need to be connected together, only that I was missing something in order to amplify the signal. So then, with a bit of help of Google, you make the base was sorted with the meter, I think. Yeah. So James, if tomorrow it's gonna be a quiet night like tonight, I'm gonna explain that one. I'm gonna build up that one on the breadboard, and I'm gonna show you when a transistor is tight base with the emitter, it's acting not anymore as a transistor, just like a diode. That's why I was asking, please check good the PCB, because if the PCB factory did it like that to be shorted, the base and emitter, I don't think so. I think it was connected base and collector. So double check again your PCB, that if it's PCB, it's a PCDD repair, if you can check, because it's in his home, that device. Because to connect the NPN, if it was an NPN, to connect the base and emitter, you are closing the transistor, like will not open at all, and so we do not allow flowing current in any direction. I can tight the base to the collector, but I must be sure that I apply less than 5 volts on the collector, and I can use that transistor as a diode to direct me the current between the collector and emitter. Give me 1 second, guys. Yes. Okay, the guys that they're waiting for you. And we have someone that is going to sleep very late tonight. He was screaming at me, Daddy, come. Say hi, guys.
Hi guys.
How are you today?
I have ordered it.
Say, how are you today, guys?
Hi all day guys.
So yeah, check again, James, because I say if it's an NPN and you connect the emitter to base, you close the transistor. Like it's no pointless.
Daddy,
Yes.
I want laptop.
You want laptop? No, we did something else tonight. A bit of theory and a bit of learning how the transistor is working. I say if it's an NPN and it's connected base to collector, because the NPN always should be collector tied to the positive, you can make that transistor act as a diode, but with the junction which is less than the normal diode. But you cannot. Sorry, good. But you cannot apply more than 5 volts to it, because then you overcross the voltage between base and emitter. Because on the base and emitter you need to stay under 5 volts to any kind of transistors, I believe. There is some special one that they may go a bit more higher, but most of them, all of them are in that 5 volts between base and emitter. Yes, in a minute, because I'm about to close this live stream because it's 10 o'clock, just to have time to prepare my lunch box for tomorrow, and then to try to go sleep, because it's 10 o'clock, you should sleep already, Gretel. Okay, guys, say bye-bye, guys. You want hi, guys, or you want bye-bye, guys?
Hi guys.
Oh, I know you want to wake up until midnight now, but we cannot, Gretel. We need to say bye-bye, and we need to go sleep. Oh, my little boy want to take over. He want to take over. He had a nap today, and when he had nap during the day, he's falling asleep very late. Anyway, guys, I hope that you learn a few things, and we're gonna carry on. I say, if it's a quiet night tomorrow, we're gonna do a part 2, showing how we're acting the same transistor as a switch, and then also demonstrate the things that was on that circuit James today was trying to fix. Rosie Rose, have a good night, everyone, and see you tomorrow evening if it's a quiet night like tonight. Bye bye now. I'm going to close. 3, 2,